Today, our task is to discover the isotopic composition of silicon, a fascinating element. Let's dive into the problem and explore its nature. According to the terms of the problem, we are told that silicon has 3 isotopes with mass 28, with mass 29, and with mass 30, but the content of only one of the isotopes, that is, the isotope 28, is given. The content is equal to 92.2%. In addition, it is reported that the relative atomic mass of silicon is 28.0855. What is required to be found? It is required to find how many percent of the remaining 2 isotopes of silicon, about which there is no data on the percentage composition. So, how do we solve this? First, let us determine the following way, that we have the entire composition. Obviously, silicon is 100%. It is all isotopes taken together, but it turns out we know the proportion of silicon 28. Then, if the total composition is 100%, and if we take away from this 100% the content of the 92 and 2% already known to us, then the remaining isotopes of silicon are 7.8%. These are both silicon, which has a mass of 29, and silicon, which has a mass of 30. Now, but since we don't know how much of each, let us in this case take one of them for content X. Let us have silicon. Let X be the mass of the first element, which is 29. The value X% represents its relative quantity. The second element, silicon, has a mass of 30. The relative amount of silicon accounts for 7.8% minus X% of the total mass. This value is derived from a silicon mass of 29. Now we substitute these values into the total expression. The result is 28.80855. This signifies the relative atomic mass of all the silicon. In this case, the ratio is obtained as a fraction of 28 times 92 and 2%. Plus silicon, which we have 29 turns out to be 29 times X%. Plus next, we have silicon, which has a mass of 30 times 7.8% minus X%. And since we're working in percentages, to get the calculation right, we'll need to divide by 100%. When we perform the calculation, the result is as follows. In this case, X, if we calculate and make such a calculation, we get that the share of X is 705%. Well, then we have this content for silicon, which is 29, and then for the share of silicon with a mass of 30, we get it will be 7.81% minus 7.05%. Then the share of the second one turns out to be 0.75000. Thus, our result is as follows. So, silicon, which has a mass of 28, according to the condition of the problem, was 92 and 2%. Silicon that has a mass of 29, it's 7% point. 0.05%. Hence, the silicon with a mass of 30 accounts for 0.75%. We have successfully solved the problem of determining the fraction of each isotope. Therefore, such tasks should be easily understood in terms of how they are solved, whether it involves percentages or mass fractions, or when the goal is to calculate the atomic mass of a specific chemical element. In the latter case, the given information will also include the isotopes that the element consists of, allowing for further calculation. This type of task can be approached both directly and inversely, whether it's finding the mass or percentages of isotopes, or even the mass of the chemical element itself. I believe you will comprehend these tasks well and be able to solve them proficiently. Goodbye.